Hey guys, welcome back to my YouTube channel. This is Mohammed Arshad. Currently, I'm pursuing my Bachelor of Engineering Student for a College of Engineering, Bengaluru. Today, I'm here with a new subject and new topic. Subject is chemistry, and the topic is about introduction to green fuels. So, as usual, we'll be continuing our video according to the agenda. So, let's see. So, in this video, we'll be discussing about introduction to green fuels. Next, chemistry of green fuels, renewable sources for green fuels, and about biofuels. There are mainly two types of biofuels we will discuss in this video. Next, hydrogen fuel cells, synthetic fuels from CO2 capture. Next, how the green fuel production is made, how the process of green fuel, environmental impact of green fuels, challenges of green fuels, and the future trends in green fuels. So first of all, we'll have a brief introduction to green fuels. So the transformative power of green fuels are revolutionary approach to energy that is shaping a sustainable future. To explore the diverse range of eco-friendly alternatives that are redefining how we power our world. So next one is the chemistry of green fuels. Green fuels are a class of sustainable energy sources derived from renewable resources at their core. The chemistry of green fuels involves harnessing the energy stored in chemical bonds of organic compounds, often produced by biological processes. This allows for a closed loop carbon cycle, minimizing the net release of greenhouse gases. So next one is renewable sources for green fuels. So first one is biomass. Is used in agricultural waste, forest residues, and dedicated energy crops can be converted into biofuels like ethanol and biodiesel. Next is solar energy. Solar panels can be used to power the production of hydrogen fuel through water electrolysis. So mainly, solar panels are used to power the hydrogen production, power the production of hydrogen fuel through the process called water electrolysis. So next is wind power. Wind turbines can be leveraged to generate electricity for synthetic fuel production from captured carbon dioxide. The next is biofuels. As we said in the agenda, mainly we'll be discussing about two biofuels. One is ethanol and another is biodiesel. So biofuels like ethanol and biodiesel are renewable transportation fuels derived from organic materials such as plant oils, animal fats, and agricultural waste. These carbon neutral fuels offer an alternative to fossil fuels, reducing greenhouse gas emissions and dependence on non-renewable resources. So ethanol is produced by fermenting sugars from corn, sugarcane, or other fibers. Biodiesel is created by chemically converting vegetable oil, animal fats, or recycled cooking oils into a diesel-like fuel. Both biofuels can be blended with conventional gasoline and diesel to power vehicles in a more sustainable way. So next one is hydrogen fuel cells. Hydrogen fuel cells are an innovative clean energy technology that generate electricity through the electrochemical reaction of hydrogen and oxygen, unlike traditional combustion engines. Fuel cells produce only water as a byproduct, making them a sustainable alternative for powering vehicles and other applications. So next, hydrogen fuel cells work by using the energy released when hydrogen atoms split into protons and electrons, which then flow through an external circuit to generate electricity. This process is highly efficient and produces no harmful emissions. So first of all, by using the energy released when hydrogen atoms they split into one is protons and another is electrons, which then flow through an external circuit to generate electricity. This process is totally produces no harmful emissions, so it is eco-friendly, we can say. So next one is synthetic fuels from CO2 capture. So carbon capture, conversion to fuel production. So when it comes to carbon capture, advanced technologies are used to capture carbon dioxide emissions from industrial processes and power plants, preventing the release of greenhouse gases into the atmosphere. So, conversion to fuels is captured CO2 is then converted into hydrocarbon fuels through a series of chemical reactions producing sustainable low carbon alternatives to traditional fossil fuels. So, the fuel production uses various techniques such as Fischer-Tropsch synthesis and electrochemical reduction and employed to convert the captured CO2 into usable fuels like gasoline, diesel, and jet fuel. So, next one is green fuel production process. How the green fuel is produced. So, we'll be discussing the process. Biomass conversion, hydrogen production, carbon capture and utilization, and the synthetic fuel synthesis. So, in biomass conversion, converting organic matter like organic agricultural waste, wood into biofuels through processes like fermentation and gasification. So, in hydrogen production, using renewable electricity to split water molecules into hydrogen and oxygen through electrolysis, creating a clean burning fuel. So, in carbon capture and utilization, capturing the CO2 emissions and converting them into synthetic hydrocarbon fuels through catalytic process powered by renewable energy. Then the last, when it comes to synthetic fuel synthesis, it says combining hydrogen with captured CO2 to produce drop-in replacement fuels like methanol, gasoline, or diesel through Fischer-Tropsch and other processes. So, what are the impacts of green fuels in the environment? We'll discuss. So, reduced emissions. Second is renewable sources, and the third one is biodegradability. Green fuels like biofuels and hydrogen emit significantly lower levels of greenhouse gases and air pollutants compared to traditional fossil fuels. In renewable sources, the renewable nature of green fuels, such as biomass and solar-derived hydrogen, it helps to reduce dependence on finite fossil resources. And the last one is biodegradability. So in this biofuels like ethanol and biodiesels are biodegradable, reducing the risk of soil and water contamination compared to petroleum-based fuels. The next one is what are the challenges and limitations of green fuels? So first is infrastructure investment, second is production costs, third is feedstock availability, fourth one is technical limitations. So when it comes to infrastructure investment, transitioning to green fuels requires significant investment in new infrastructure such as refueling stations and distribution networks, which can be a major barrier especially for developing countries. So in production cost, many green fuels like biofuels and hydrogen are still more expensive to produce than traditional fossil fuels, making them less competitive in the market. And feedstock availability. The availability of sustainable feedstocks like biomass or renewable hydrogen can limit the scalability of green fuel production in certain regions. So last one is fourth one, technical limitations. Some green fuel technologies like fuel cells still face technical hurdles around efficiency, durability, and cost that need to be overcome. So in last, what are the future trends? What are the future of green fuels in energy transition? First is widespread adoption. Second is technological advancements. Third is policy support. So in widespread adoption, green fuel becoming mainstream in transportation and industry. So technological advancements, improved efficiency and cost effectiveness of production processes. So in policy support, favorable regulations and incentives driving green fuel deployment. So what it means, with continued technological breakthroughs and growing consumer demand, green fuels are expected to become increasingly prevalent in powering the transportation, industrial processes and more. This transition will be essential for reducing greenhouse gas emissions and building a cleaner, more resilient energy system. So that's it for today, guys. Hope you liked this video. If you like this video, please like, share, and subscribe. Thank you.